Just want to talk real quick about this homework problem. I didn't actually intend to assign something. It's not bad. It's a little more difficult than I would intend to normally assign. If you go back and rework this problem where instead of, I thought they had given you this magnitude, the magnitude of AB. If you work this problem where they give you the magnitude of AB as 160 pounds, and then you've got an unknown magnitude of AC and theta. This problem's actually real simple. You set up to where you've got, you can find the tangent of this angle is equal to some constant. The arctangent gives you this angle, and that's real simple. As it's set up, knowing this magnitude, not this one, and this is an unknown angle, there are solutions, and some of you guys made some beautiful angle substitutions where you employ a trig identity and you got to do a quadratic equation, and kudos. Great work. I did want to show you how I might try to approach it. If you look in the solutions manual, they'll say use guess and check method. Here's how I graded this, right? First and foremost, if you got your sum of forces in the x direction and your sum of forces in the y direction correct, then I gave you 10 out of 10. That was really, because at that point you've set up, you've done the statics problem, and everything after that is just algebra and trig, which is good, and it's really good that you build up a skill set of working through difficult algebra and challenging mathematic problems, and that is important. This one was a little more than I normally like to assign homework, and that's okay. So here's what you want to do, right? Get this down to, so you got sum of forces in the x direction. You can set one unknown AB in terms of the other one cosine theta. And then you go to your sum of forces in the y direction. Now AB and sine theta are still unknowns. But you plug this in for AB. Right? And you get this expression where I've only got one unknown, theta. And go ahead and pause this if you need to. I'm not sure. It looks like my screen's glitching. I'm not sure what's going on there. But anyway, if you need to pause this to kind of get some detail there. And this was, I thought, probably the simplest way to simplify it is just get sine theta with a coefficient of 1, and then you've got some coefficient there for cosine. Set this equal to 0, and then I would go to a spreadsheet software. Let's see here. So I've just got Google Sheets, which I find I would much rather work with Excel, but I'm on a Chromebook right now. I don't have Excel installed, but I can get by with Google Sheets here. So I had this formula. This is equal to the sine of theta. Now, most spreadsheet softwares, like most softwares in general, are going to want that angle in radians. So I'm going to set it equal to this cell here. I'm going to put an angle in that cell in just a second. But it's going to equal to that cell there. And if you look at the formula that I had earlier, so if you back up, get the formula that I had, pause it, write that down. But it's sine theta plus 0.8391 times the cosine of theta. So I'm going to set theta equal to this cell right there. I'm going to put a value for theta in that cell. And it's going to be minus the 1.25, which is the result of the 200 pounds divided by the 160 known pounds. And I'm going to set that, and what I want this value to equal 0. Now right now I've set it equal to an angle right here. What I'm going to do is I'm going to put in this cell radians, because I normally think in degrees. I'm an engineer, not a mathematician. So I'm going to find the radians of some value in this cell here. Right? Now right now it's 0, and what I know is the most that angle is going to be is 90, and the least it's going to be is 0. That's going to be an angle somewhere between 90 and 0 degrees. So you see we go from 90 to 0, and let's say that it's somewhere in the middle, 45. And notice what's happening. This value over here is calculating, and I want to find a value of theta such that this approaches or gets as close as I can to 0. So what I'm trying to do is I'm trying to zero in at a point where it goes to 0. So here I've got a positive 0.05 at 45 degrees. And if I go back to, let's say, 30 degrees, it's negative. So somewhere between 30 degrees and 45 degrees, I've got a value. Now, if you use a Microsoft Excel spreadsheet software on a desktop, there's a function called goal seek. And you can set this up to where I've got a formula in this cell is based on some formula in this cell. And you can tell goal seek, change this cell until you get a value of this cell to be 0. I didn't find that in Sheets, and I didn't find it in a web version of Excel I've got access to, but you can do it by what we call brute force. So somewhere, again, notice at 45, this is a positive, this guy over here is a positive 0.05, and then if I go to 30, it's a negative 0.023. So somewhere in between there is a 0, and that's what I want, is I want this value to equal to 0. That's going to be a solution for me. So if I go to, let's say, 35, notice now this is a positive value. So somewhere between 30 and 35 is a 0. And so I'm just going to kind of, let's split the difference. Let's go to 33. 33 is now a negative value. Notice that's really close to 0. So somewhere between 33 and 35 is a value that I'm looking for. 34, so it's somewhere between 34 and 33. And notice to 3 significant figures, we are approaching 0. So let's say 33.5. So it's, and notice from between 33 is negative and 33.5, 33.5 is positive. So somewhere in between those two is a 0. So I'm going to say 33.25, right in between the two. And notice that is just, to 3 significant figures, that is 0. And in fact, when I look at the solutions manual, that is in fact the answer they give, is 33.25 degrees is the angle. But you saw what I did there. I knew somewhere between, and how did I know? Well, I just kind of guessed, honestly. I just thought, 30 is a common angle and 45 is a common angle. So somewhere between those 2 common angles is an answer because it goes from negative to positive. And what I did, again, is I set this equation here equal to 0. And I plugged this equation into my spreadsheet. All right, so I plug that equation into this spreadsheet. And I set this angle here. This is the radians version of this angle. So this basically is, this is theta degrees. This is theta radians. And this should be 0. And so this is my formula here from my work. All right, that's my formula. That should equal 0. So I'm just going to change this value, theta in degrees. And if you zero in, you get about 32.25 degrees. You get essentially a 0 there. So that's a way to solve this. Some of you guys solved it mathematically. Great work. I wanted to show you kind of a brute force math tool that you could use. Very simple, very easy way of doing this. Obviously, you couldn't do this on a test. You could maybe do that on a calculator if you're really good on your calculator, but it's going to take a little bit longer. But I just wanted to show you a way of finding that unknown angle using tools that a normal engineer might actually use. Excel, I mean, we could program a crazy MATLAB expression to find this, but if you know how to use a simple spreadsheet, doing something like this is actually very simple. All right, I'm going to stop there. Let me know what questions you guys have, okay?